In this lesson, we're going to learn about midpoint theorem. So we will start with this question to prove the theorem. We are given that M and N are midpoints of the line AB and AC. We are asked to show angle AMN is equals to angle ABC. In order to do that, we will use similarity test. Since we know that these two lengths are equal, and these two lengths are equal because of midpoints, we have AM over AB will have the same ratio as AN over AC. These two lengths need not be equal, but the ratio of AM over AB is 1 over 2. The ratio of AN over AC will also be equals to 1 over 2. So we have SS for the similarity test. So what else do we need? Yes, we will need an included angle. Here, angle MAN will be equals to angle BAC because they are both common. Therefore, triangle MAN is similar to triangle BAC. And we will have SAS similarity. Now, for similarity test, you must write the word similarity. Since these two triangles are similar, we can now say that angle AMN will be equals to its corresponding angle ABC. How do we prove that MN is equals to half of BC? This is using the same property of similar triangles. MN over BC will have the same ratio as AM over AB. Because the ratio of the corresponding lengths are all equal for similar triangles. And the ratio we have is half. So using these two parts here, we can say that MN equals to half BC by just cross multiplying over BC. So this will lead us to what is known as a midpoint theorem. Midpoint theorem states that if M and N are midpoints of sides AB and AC, we can conclude that MN will be parallel to BC. Because previously we have shown that these two angles are equal due to similarity test. In order for them to be corresponding angles, MN must be parallel to BC. And because they are similar triangles, we also found out that MN is equals to half of BC. So whenever we are given midpoints M and N, we can say that MN must be parallel to BC, and the ratio of MN over BC must be equals to half. whenever you write these two down, you just need to indicate that it is due to midpoint theorem, and you do not need to prove similarity test, but just write down the property midpoint theorem. Now let's see how we can apply midpoint theorem in an example here. There are two parts to this question. The first part asks us to prove that PQRS is a parallelogram. Now points P, Q are midpoints of the bigger triangle ABC. Points R and point S are also midpoints of the smaller triangle OBC. So how do we prove that PQRS is a parallelogram? To prove that a quadrilateral is a parallelogram, there are two ways to do so. One way is to prove one pair of equal sides and the same pair of equal sides must be parallel. Another way to do so is to prove two pairs of parallel sides. So let's see which one can we prove. Since we know that PQ and SR are all midpoints, then we will try to see if we can apply midpoint theorem. So PQ will be half of BC because of midpoint theorem. Similarly, SR will be half of BC because of midpoint theorem. Because of these two equations, we will know that PQ equals to SR. So we have one pair of lengths that are equal. We should also show that we are going to prove this one. The next thing to do now is to prove that these two lengths, they are equal, they are also parallel. So to do that, we need to use midpoint theorem again. PQ is parallel to BC based on midpoint theorem. And SR is also parallel to BC based on midpoint theorem. And in conclusion, PQ is parallel to SR. Since PQ equals to SR and PQ is parallel to SR, therefore PQ RS is a parallelogram. Hence, we are asked to show that OS equals to 1/3 BQ. So OS is here, and BQ will be the longer length. Since S is the midpoint, OS is equals to SB. Since PQRS is a parallelogram, OS must be equals to OQ because the diagonals of parallelograms bisect each other. So we will write this down. the diagonals of a parallelogram bisects each other. So this will be one part, this will be one part. And from here, we know that if this is one part, BS will also be one part. So, in conclusion, OS will be equals to 1/3 of BQ shown. You can pause the video now and try practice 3, which asks you to prove that angle SPT is equals to angle OBS, and the ratio of TQ is to AB will be equals to 1:4. Additional info is that PQ are midpoints, and this ASB here is a semicircle. Okay, I hope you are able to find the solution. So let's go through the solution now. Angle SOB is 90 degree. OS, OB, OA are all radius. So we know that triangle OSB, OAS are all isosceles triangle. And what is the value of this angle here? Angle OBS will be equals to OSB as well. Angle OAS will also be equals to angle OSA. Both will be using the same method. It is 180 degrees minus 90 divided by 2 because of base angles of isosceles triangle. And they will all be equals to 45 degrees. So we need to show that this angle is also 45. And yes, we will use midpoint theorem because midpoint theorem can help us to say that PQ is parallel to AB. Okay, therefore, angle SPT will be equals to angle SAO, which is 45 degrees corresponding angles. Since SPT is 45, OBS is also 45. We have proved part A. For part B, we are asked to show that TQ is to AB is 1:4. Likewise, we'll use midpoint theorem again. So PQ over AB, PQ over AB is 1/2 because of midpoint theorem. Triangle SPQ is an isosceles triangle because this angle here, due to corresponding angle, is 45 degrees. This angle, because of proven earlier, is also 45 degrees. So SPQ must be an isosceles triangle. Also, because these two lines are parallel, angle STQ or angle STP is also 90 degrees. So triangle SPT and SQT must be congruent triangles. And we have ST being common. So we have triangle STP will be congruent to triangle STQ because of ASA, angle side angle. And T is the midpoint of PQ, or PT is equals to QT. Now you may use other methods to show that T is actually the center. So TQ over AB is actually half of over 2. If PQ over AB is 1 over 2, TQ over AB must be half over 2, and that will give us 1 over 4, and hence TQ is to AB is equals to 1 is to 4. Now you may use other methods to prove this. Okay, this is but one of many other methods.